Hi everybody, thank you very much for providing us an opportunity to present our results entitled Modeling Feed Energy and Protein Values for Ruminants, presented by our team, Pak Ridla, Bu Erika, Pak Nahrawi, and me, myself, Anurata Jaya Negara. We are from Faculty of Animal Science at the University in Bogor. As an introduction, feed formulation system for ruminants in Indonesia currently for the energy system is based on total digestible nutrient, the amount of nutrient that can be digested by animals. And for the protein system, we still use the crude protein system, in which the system is considered as being obsolete or not updated anymore, since in the developed countries, the system for energy is within the form of net energy or at least metabolizable energy, while the protein system is typically based on metabolizable protein, the protein that can be digested and absorbed in the small intestine. Our system is based on total digestible nutrient or TDN. However, the TDN itself is estimated from proximate analysis. It is not typically not directly measured in the field, but it is more or less estimated from the chemical constituents of the feedstuffs. Our concern is whether the TDN itself is an accurate representation of feed energy and whether we could predict the current system in the developed countries based on net energy and metabolizable energy from the old system, from the TDN. Whether the prediction is accurate or not, we are not sure. With regard to protein, our main concern is whether dietary crude protein, which is the known system, is still accurate to predict the protein metabolism and utilization in ruminant animals. Basically, the dietary crude protein, when it is entering the rumen, it can be divided into two main groups. The first one is rumen degradable protein or RDP, and the second one is rumen undegradable protein or RUP. Our second question is whether is there any optimal ratio between RDP, degradable protein, to RUP, to undegradable protein ratio. So this really determines the protein partition. And from these two main groups of the protein, finally it could be converted into so-called amino acids, and these amino acids is later on being absorbed in the small intestine. And these amino acids is actually the metabolizable protein, the protein that can be digested and absorbed in the small intestine. Whether can we predict the metabolizable protein from the old system, from the crude protein? Therefore, the objective of this study is firstly to assess the relationship between TDN, total digestible nutrient, and metabolizable energy, and between crude protein and metabolizable protein, basically to compare to see the relationship between the old system and the new system. The second objective is to estimate feed metabolizable energy and metabolizable protein contents from their chemical constituents. And the third one is to obtain optimum ratio of RDP to RUP. For the materials and methods, we use feed database from Brazilian system, so-called BR Corte. There are 134 feeds, and within these feeds, they are characterized with their chemical constituents: dry matter, organic matter, NDF, lignin, non-fiber carbohydrate, extra extract, total digestible nutrient, metabolizable energy, crude protein, RDP, RUP, and metabolizable protein itself. Why we use the BR Corte or the Brazilian system? Because the situation and the feed diversity is more or less comparable to our condition, which is within the tropical belt, and with rainforest, lot of rain, mainly in the country. So for the statistical analysis, to observe the relationship between TDN and ME and CP and NP, we use linear regression analysis. To predict the metabolizable energy, we use some independent variables such as natural detergent fiber, non-fiber carbohydrate, ether extract, and crude protein. And to predict the metabolizable protein, we use two independent variables, that is rumen degradable protein and rumen undegradable protein. To assess the optimum RDP to RUP ratio, we consider that the optimum ratio will be leading to a maximum metabolizable protein, and therefore we make a regression analysis, but this is nonlinear regression. We employed the broken line or segmented regression analysis. Results show that when we plot between TDN in x-axis and metabolizable energy in y-axis, we could see a strong relationship. From 134 feeds, we could see a very strong relationship between TDN and metabolizable energy. This means that the old system still could predict accurately the current energy system. The old system, which is the TDN system, could be useful or still useful to predict the metabolizable energy content of feed. With regard to the current protein system, which is metabolizable protein, surprisingly that the crude protein content in the feed is really accurately predicting the metabolizable protein with single predictor only by the crude protein itself, with the R square above 0.9. This again shows that the old system is still useful if we are lack of laboratory facility to derive the metabolizable protein content in feed, then using the crude protein content for formulating diet for animals, particularly ruminants, is still useful. To estimate the metabolizable energy and metabolizable protein contents from various chemical constituents, we could use these equations, these multiple regression equations, by employing a number of independent variables as I mentioned before. The metabolizable energy content could be accurately predicted from the non-fiber carbohydrate, natural detergent fiber, ether extract, and crude protein. These chemical constituents are basically the carbohydrate, lipid, and protein contents, and they are contributing to a certain amount of energy, and therefore making the summing up the metabolizable energy. For the metabolizable protein, it could also be predicted accurately from the RDP and RUP, in which the RUP contributes more as compared to RDP for the metabolizable protein. We could see from the slope of these two variables. These two equations resulted in R squares above 0.9, which are very accurate. To observe the optimum RDP to RUP ratio, we prepared a plot between RDP to RUP and the metabolizable protein as a percentage to crude protein content. So we could see that the RDP to RUP ratio of 3.3 or equal to RDP 76.7% and RUP equal to 23.3%, it is the value where if we try to increase the RDP proportion, it doesn't make any change or less change to the metabolizable protein. But when we reduce the proportion of RDP, we could We could clearly see from the left side of the figure, we could see that there is an increase of the metabolizable protein in proportion to crude protein. This means that rumen and degradable protein, undegradable protein in the rumen contributes to more metabolizable protein, provided that the RUP could be used, the bypass protein in the rumen could all be used in the small intestine, could be digested. In conclusions, there are strong relationships between TDN and ME and between crude protein and metabolizable protein. The second conclusion is that the chemical constituents could accurately be estimated from ME and MB contents, and lower RDP to RUP ratio leads to higher M proportion to crude protein. Thank you very much for your kind attention.